And welcome to the first lesson here in Module 5, looking at rational expressions and how to simplify those things. You should have your student edition of the unbounded lesson provided hopefully by your teacher or something like that. I'm going to be going through the student PDF, and it should look just like this with the blanks and everything, and we'll fill it in together as we go. Don't forget that you should pause the video before some of these questions to try them on your own first, and I'll kind of prompt you to do that sometimes too. Doing them first before I do them will help you to learn more, because you'll kind of see what you were thinking and compare it to what the correct way to do it is, or confirm that you did it the correct way, and then go from there. Okay, so we're going to skip this opening exercise because it asks you to kind of do it with a partner. So, I mean, we could kind of just look at, writing two fractions that are equivalent to 1/3. So, I mean, I could kind of like draw 3 bars here, for example. Let me see if I can kind of connect that better. And I'll try and draw them all the same length at least. And so we could draw 1/3 like this. Just split the bar into 3 equal sections and shade in one section. That's equal to 1/3. Okay. We could also, though, do that same 1/3, and we could split them further in half. So split each one of these individual bars in half, and then we would shade in, well, how many are there? 1, 2, 3, 4, 5, 6. So if we shade in 2 of those, that would be equivalent to 2, 6, which is the same thing as 1/3. And we could go one more step further if we wanted to here. Oops. Again, do our thirds. And we could split those into thirds as well if we wanted to. In which case we have 9. And again, to get this equivalent 1/3 fraction here, we would shade 3 of these. And so that would be 3/9 or 1/3. Okay? The point here is to see that all these fractions are saying the same thing. So in other words, 1/3 is equal to 2/6 is equal to 3/9. And the reason for that is we can rewrite 2/6 as 2/2 times 3, right? And we can rewrite 3/9 as 3/3 times 3. Okay, so in the first fraction, right, there's nothing in the numerator and denominator that cancels. However, in the second fraction here, we can cancel out the 2 and the 2, leaving a 1 and a 1 behind, or in other words, a 1/3. Here in the third fraction, we can cancel out the 3 and the 3, leaving behind a 1 and a 1, and again, getting a 1/3. So, kind of refreshing on our simplification of fractions there. In this first example, then, we're asked to consider the following rational expression. So a rational expression, by the way, is just a fraction, okay, that can have variables or numbers in the numerator and denominator. Okay, so we're going to be simplifying these here in this lesson. So again, turn to your neighbor. That's not something we can really do with these videos here, but we can at least answer the question. So looking at this, right, we want to know for what values of a is the expression undefined. Now, that word undefined means divide by 0, right, or when the function would divide by 0, which we know is a big problem in mathematics. It's kind of an undefined, well, it's literally undefined, right? We don't know necessarily what it equals all the time. So let's take a look at our rational expression here. Okay, right away we can see we can do some simplification. So let's go ahead and simplify things here. I'll distribute the 2, make it 2a minus 2 minus 2, and then 6a minus 6 minus 3a. And combine like terms. So we'll get 2a minus 4 in the numerator, and we'll get 6a minus 3a is 3a minus 6, like that. So now what we're going to do is determine what a value here in the denominator will make the denominator 0. Now you might be able to look at that and just do some mental math and figure out what a value will give you 0 when you plug it in to the bottom there. But if you can't do that, the easiest way to go is to take 3a minus 6 and set it equal to 0. We don't want it to be 0, so let's set it equal to 0 to see what value we don't want a to be. So we add 6 to both sides. We get 3a equals 6, divide both sides by 3, and so a is 2. Okay, so in other words, we want a to not be 2. If a was 2, we would get a 0 in the denominator. Okay, if a was 2, we would also get a 0 in the numerator, though, as well. Okay, and so that 2 would be, when you get 0 over 0 like that, this is known as indeterminate form. Sometimes it does actually equal a value, okay? But for this purpose, I think for the lesson here, they want us to say that. So we'll stop there, and we'll come back to this and look at exercises 1 through, well, a few here at least. So, yep, see you next video.